Hello, I'm Brandon Lamoncha from Hometown Products, and I'm the Director of Additive Manufacturing.
Hi, I'm CR Peterson, and I'm the sales leg for the conventional cores at Hometown Products. Most customers use conventional cores, or we steer them to conventional core manufacturing when they have either a medium or high volume core usage, and they have existing tooling. That is a couple hundred cores frequently, or thousands of cores. Now, to us, a high volume job is in the tens of thousands. But if in fact we can produce the core in a conventional manner and it's a cost savings over 3D, we will steer you in a conventional direction. Basically, what we do is we'll produce the larger mold section that may not have a lot of geometry involved in it, and we can do it in air set and keep the cost down of the larger portion. Because it's a bigger area and more cubic inches, that's a higher cost. And that mold may be able to be produced out of a conventional box at a much lower price. And then we produce the 3D core with the detail and add it in to the mold.
A few main differences, obviously on conventional core making, we have to have tooling, and that can, have a considerable lag in being able to get that tooling, into our facility. So a lot of times we'll have a lead time that's longer, not only because we have to get the tooling in, but once it comes to our shop, we have to rig it for our core blowers. Whereas in 3D printing, as soon as I get the CAD file, as soon as we have open capacity, we can throw that into a job box and we can start printing that core, sometimes as early as the same day. We're currently printing, we have a few blends where we blend, ceramic and silica or zircon and silica, but the additives are also very important in the printing process for steel foundries. When I add black iron oxide, anywhere from 1 to 4% by weight. And then we also use a KBF4 mag inhibitor, which is good for magnesium castings for in the aerospace industry. Hometown has a wide variety of washes. Typically, one would be like a graphite coating. The other is a zircon, but we have had custom washes in the past, per client needs, and we can, accommodate if, if there's justification based on quality, quantity. 3D printers that Hometown currently has are basically, you can print a mold or core section in one piece that's about 70 inches long by 39 inches wide by 27 inches tall. Now, we have had customers that have had molds or cores larger than that, and all we do is basically take like a Lego approach and we pin and bolt those sections together, and then we're able to achieve a much larger core mold. So Hometown has always been, very innovative, and we always like to think outside of the box. So, we work with coating companies, resin companies, sand. We're trying to print different types of media almost, weekly. Whether it's a different type of sand or ceramic, or we've experimented with several different zircon and chromite sands. So I think it's very important to not just get locked into one material set. And we come alongside all of the industry that's serving foundries traditionally, and we're trying to incorporate that into 3D printing. There's a lot of really good metal casting processes that we want to mimic and come up along beside and incorporate that into 3D printing, and not have it being an us versus them scenario.
Well, this is having the 3D leg of the stool is a wonderful thing. And that helps all customers, because even on newer projects where we're designing and building tooling, the tooling will sometimes be delayed. Pattern shops get behind the curve. Changes need to be made in process. And what that allows us to do is not only do the prototype cores in 3D, but allows us to get them started in production with 3D while the tooling is being manufactured to produce the conventional cores.
Dual path is something that's becoming more and more popular. We're starting out using 3D printed cores in the process for, new product development or prototype, but then what it will turn into sometimes is bridge production. So, while a tool is being produced or being CNC cut, we're able to continue to get castings, for the customers that need them. And then once the tooling is made and being PPAP, we can still be coming alongside with the 3D printed cores and still being able to produce cores for customers, while they're in that development phase, tooling phase. But then also, if there are surge demands and, once a tool is in production, if we're at capacity in our Columbiana facility, we can actually turn, or if that tool goes out of service due to, wear or, there's damage to it, we're able to come alongside and, really 3D print cores and use that as a dual path, enabling, to keep production volumes high.
But I see at some point that once high-speed printing and the costs are driven down, that at some point, I believe that tooling will, in fact, not be an important role in the foundry industry. The costs have to get reduced for 3D, and that will be with high-speed printing. The more machines get out there, the more foundries accept the process and understand the process, will move that along a little bit faster. But by and large, at some point in time, everything will be changed over and be produced by additive manufacturing of some type.
We're breaking out of the prototyping arena a little bit, and we're really starting to see repeat customers convert core boxed jobs into 3D printed production orders. And for us, that's very exciting because it kind of shows that the future of the core room really does reside in 3D printing, because typically the cores are the most complex. That's where a lot of the defects happen, whether it's gas or whether it's, misassembly or glue joints. So, as a core shop at our heart, we really want to break into this new opportunity of using 3D printed cores as full-on production. And a lot of our customers are coming along beside us, and we're very excited about that.